Carbon overcomes this problem by sharing its valence electrons with other atoms of carbon or with atoms of other elements. What does this mean? Carbon will not give electrons, will not lose electrons, or carbon will not gain electrons. Instead, what will it do? It will share electrons. Remember, students, when there is gaining or losing of electrons, then they are ionic compounds, ionic bond. Here it is not like that. What does the carbon do? It will share valence electrons with what? With other atoms of carbon, or else other atoms of other elements also. Not only carbon, there are other elements also which form molecules by sharing electrons in this manner. And the shared electrons belong to the outermost shells. What does this mean? For both the atoms which are sharing the electrons, they can share the electrons present in the outermost orbit only. Please keep this in mind. Only the valence electrons, the outermost electrons only can be shared. So, before we learn the sharing of carbon compounds, let us first understand the simple molecules formed by other elements. The simplest molecule which is formed in this manner is of hydrogen. We have already learned that hydrogen has atomic number 1, which means hydrogen has 1 electron. So, if we draw electronic structure or electronic configuration for this, it will be as shown in the figure. Hydrogen will have only one shell, one orbit. In that, 1 electron will be filled. But we know that in first orbit, how many electrons can be filled? 2. Here, how many we have? Only 1. Okay. So what will hydrogen do? Hydrogen will share electron. You will think hydrogen cannot give electron. If hydrogen gives electron, then what will be left? Only nucleus. That is not possible. So, what will hydrogen do? Hydrogen will share its 1 electron. How? Let us see. Here we have 2 hydrogen atoms, okay, for sharing electron. So, whatever you are saying, H in circle, that is hydrogen atom, and that cross sign which you are seeing, that is sign for electron. Okay, so that is sign for electron which you will remember. Okay, so when we have 2 hydrogen atoms, both will have 1 electron in its outermost orbit. Okay, so what will they do? They will share their electrons, and when they share their 1 electron, this way shared electron will be shown. How? Combined, as you can see in the figure, and it is said as H2 molecule, 2 hydrogen combined. That is why it forms H2 molecule. We know when there is a single, it is atom. When 2 atoms are combined, it forms molecule. So here we have hydrogen molecule. And as a result of this, hydrogen atom will try to attain electronic configuration of the nearest noble gas, which is helium, okay, which has 2 electrons in its k shell, first orbit. We know that all the elements will try to attain their configuration as noble gases. Okay, so the nearest noble gas to hydrogen is helium, so it will try to attain its electron like helium, and as a result we get this H2 molecule. The shared pair of electrons is said to constitute a single covalent bond between the two hydrogen atoms. And how it is represented symbolically as shown in the figure. H in between one line and then again H. One line means what? Single bond. Okay, it is very easy to remember. One line means single bond. So between two hydrogen atoms we have single covalent bond. Now I want you to remember the definition of covalent bond. The bond which is formed between two atoms by sharing of an electrons is called covalent bond. Okay, so this is single covalent bond between two hydrogen atoms, and it will look somewhat like this by sharing of electrons. Now let us take another example, which is of oxygen. We know that the atomic number of oxygen is 8. So, in the first K shell, that is first orbit, we have 2 electrons, and in the second orbit, that is L shell, we have 6 electrons. In this way, we have electronic configuration as 2, 6. Oxygen also forms compound by sharing of electrons. How is it so? Let us look. So this is the bond between two oxygen atoms. Again, I am saying you that the crosses which are shown, they show electrons. Okay, we can use to represent electrons, we can use cross or dots. Only these two signs we can use. Okay, remember, dots or cross. So here we have taken oxygen atom and cross sign for electrons. So 2 oxygen atoms are there, which means how many electrons? 6 electrons. Why are we taking 6 electrons, students? Otherwise it has 8 electrons, because we have to take its valence electrons. Again, remember, only valence electrons are shared. That is why here we have taken 6 electrons of oxygen. As shown in the figure, the electrons will be shared. Now, understand the figure very properly. How many electrons are shared in between? 2 electrons from one oxygen atom and 2 electrons from other oxygen atom. Why only this many electrons are shared? Can you think? Try to get the answer. See, here in outermost orbit of oxygen, it has how many electrons? 6 electrons. How many electrons will it need to attain octet configuration? 6 it has. It will need how many electrons to get octet configuration? 2 electrons. When it will get 2 electrons, then only it will have 8 electrons in outermost orbit. So it needs 2 electrons to form octet configuration. That is why it will share 2 electrons. Okay, so 2 electrons from one oxygen atom and 2 electrons from other oxygen atom. Students, please remember this. It is very much easy. See, when first of all we'll write valence electron, which are 6. Then we will represent it in the figure, and 2 electrons from one atom, 2 electrons from other atom will be shared. Why? Because in outermost orbit 6 electrons are there and it needs 2 electrons to get octet configuration. Okay, now as it shares 2 electrons from one atom, it will have double bond. So between oxygen atom we have double covalent bond as shown in the figure. Now as it is double bond, How will we represent? With two lines. O, then two lines, and then O. So that shows double bond between two oxygen atoms. Now, here you need to note that it cannot only form covalent bond with other oxygen atom. It can form it with other atom of other elements also. So after sharing, it will look somewhat like this. This is double bond between oxygen. Here you can see clearly two electrons shared from one atom and two from the other metal. Let us take one more example of nitrogen. Nitrogen has atomic number 7, which means in the first orbit it has 2 electrons, in the next orbit it has 5 electrons. 2 plus 5, 7. How will be the covalent bond between nitrogen? Let us see. It will have bond like this. First of all, nitrogen atoms we have to write. So 2 nitrogen atoms. And how many cross sign we can say? 1, 2, 3, 4, 5. 5. Why is it so? Recall. Because it has 5 electrons in its outermost orbit. So, now if we are asked to draw this configuration, so like the circles we will draw. And then we will represent shared electrons. The middle part shows the shared electrons. How many electrons will be shared? You say me now. I am sure in your mind you got the answer. Nitrogen will share 3 electrons. Why is it so? Because we need to remember that nitrogen has 5 electrons in its outermost orbit, right? How many more electrons will it require to get octet configuration, which means 8? It will need 3 electrons because 5 plus 3, 8. That is why nitrogen will need 3 more electrons. So, here nitrogen will share 3 electrons with other 3 electrons of another nitrogen atom. And that is why it will form nitrogen molecule. And here what type of bond it will be? It will be triple covalent bond. Okay, and as shown in the figure, it will be shown with 3 lines. So this is triple covalent bond between nitrogen atoms. You will be thinking how to decide it is single bond, double bond or triple bond. So you can remember it easily. How many electrons will be shared, that will be the number of bond. For example, one hydrogen atom share 1 electron. That is why between hydrogen atoms it is single bond. In the case of oxygen, oxygen was sharing 2 electrons. That is why it is double bond. 2 means double bond. In the case of nitrogen, nitrogen is sharing 3 electrons. That is why it is triple bond. Very much easy to remember. Here the signs are shown: single bond, 1 dash, double bond, 2 dash, and triple bond, 3 dash lines. Not a dash, lines. Okay, so this way you will remember. So after sharing electrons, nitrogen will have this type of triple covalent bond. Again remember, it is sharing 3 electrons. That is why it has triple bond. Oxygen was sharing 2 electrons. That is why it has double bond. One oxygen atom share 2 electrons. That is why. And one hydrogen atom share 1 electron. That is why it has single bond. Now let us understand example of water. H2O. We know that hydrogen atom has 1 electron in outermost orbit. Here we have 2 hydrogen atoms. Okay. Oxygen has how many electrons in outermost orbit? 6 electrons in outermost orbit. how many more electrons oxygen will need to get octet configuration? It will need 2 more electrons. So how will it get? 1 electron from one hydrogen atom and 1 electron from the other hydrogen atom. And this way, this is the formation of covalent bond between 2 hydrogen atoms and 1 oxygen atom. Can you say which type of bond it is? Single bond or double or triple bond? I know that you can say it easily. Here, one hydrogen atom shares electron with oxygen. So only one electron is shared with outermost orbit electron of oxygen. So that is H single bond O. On the other hand, other hydrogen atom also shares one electron only. So that also will be single bond. Together it will be HOH single bond. So this way you can understand it better. Here cross and dot both signs are used. For electrons of oxygen we have used dot, and for electrons of hydrogen we have used cross sign. So one electron of hydrogen and one electron of oxygen. Same way on the other side, one electron of hydrogen and one electron of oxygen are shared. So this is covalent bond in water, H2O. This is the electron dot structure for methane. What is the formula of methane? It is CH4. Now, carbon has 4 electrons in its outermost orbit. All hydrogen has 1 electrons. So all 4 electrons of carbon will be shared by 4 hydrogen atoms as shown in the figure. Red color, that is electron from hydrogen, and blue color, electron from carbon. This way, this is the electron dot structure for methane. We can also draw electron dot structure for other compounds also. Now from this we can conclude that the compounds which are formed by covalent bond, they have strong bond within the molecules. In between molecules they have strong bond, but intermolecular forces are weak. And because of this, intermolecular forces are weak. Because of this, they have low melting points as well as low boiling points. So this is all about the main topic, that is bonding in carbon, the covalent bond.